So I have put some of the topics for today, and those topics are, let me see if my memory is serving me okay. We are going to talk about coordinate planes, and then we will talk about related and unrelated variables. And there was one more topic that I had planned, that was patterns in a coordinate plane. So I don't think we will be able to cover all the topics in one class, but we'll see how much we are able to do. Okay. I see Sid has not disconnected yet. So Sid, I'm removing you from the class, okay? Otherwise, I'll not be able to pay attention to the screen. I'm looking at everybody in the class and trying to see who needs help, who is clear, who is not clear, right? So okay. So Aditri, am I guessing the name right? Aditri. Okay. So we'll talk about coordinate planes. Now it will be unfair if I assume that you guys don't know about what is coordinate plane, right? Everybody knows what is a coordinate plane. Yeah? And going by my habit, I will make it even look more dumb than you guys think about. Meaning I'm saying I don't know what is a coordinate plane because I look at it in a much more simplistic way. I don't look at coordinate plane as a coordinate plane. I look at coordinate plane as two number lines meeting each other this way, in a perpendicular way. This is one number line with 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. And this is one number line, 1, 2, 3, 4. And here minus 1, minus 2, minus 3, minus 4. It goes on. So these are two number lines meeting each other at 0, 0. In a perpendicular way, meaning they are making an angle of 90 degrees. So let's not worry about the angle right now, but yeah. This is how, for me, coordinate plane is nothing but the two number lines meeting each other this way. Now we have to give some name to them, right? So this is x, this is called x-axis, this is called y-axis. So these two number lines together, when they meet each other at 0, 0, this way, this is given another name called coordinate plane. Now you guys must be thinking, why are we spending or wasting time on something that we already know? Because this is your foundation for trigonometry, for three-dimensional geometry, volume, surface area, whatnot. Okay? So this is going to get very intense as we speak. That is why before the intensity increases, we want to make sure that this stays glued with us like a simple concept. Like I said, I am not even calling it a coordinate plane. I am saying that these are two number lines meeting each other this way. Yeah? And I'm not done yet. I've just started. I'll just tell the tip of the iceberg. Okay? So, Sanvi, Aditri, Isha, can you guys keep your video on, please? Sanvi. No, it's okay. I mean, see, I'm just borrowing that confirmation from you guys. Okay, when I look at, see, when I'm looking at Anahita's face, I know Anahita is with me. She is able to make sense out of whatever I say or not, right? So that's my only reason for asking for it. Thank you, Isha. Yeah. Okay. Here comes Mr. Ishan. And where is Adya? So between Adya, I'm sorry, what? Okay. Okay. So Ishan, keep your video on. We just started. I know we are late by a few minutes today, but we are talking about coordinate plane. And why we are talking about coordinate plane? Because this is the foundation for what we are going to learn with much more intensity, much more complexity in coming weeks, months, years even. So now this is a coordinate plane. This is one number line, this is another number line meeting at 0, 0 this way. Now we are trying to get further deeper into it. We clearly see that this coordinate plane is breaking my screen into 4 pieces. This is one piece, this is second piece, this is third piece, and this is the fourth piece or fourth part or fourth. This is one quarter of a screen, this is second quarter, third quarter, fourth quarter. We don't call it quarter, we call it quadrant. So this is first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. Okay. Now we know what are these called. Any point that we locate. Why are we even talking about the coordinate plane? Because it helps us locate the points. Let's say if I'm talking about this point on the screen versus this point on the screen, I will use this coordinate plane as a reference to locate these points. If I look at this point, let's say here it is -3, -4, -5, -6. So my x value for this point is -6, and let's say this is 4. My y value is 4. So this point is represented as a 2-dimensional coordinate called -6, 4. So when you look at the coordinates of any point or the whereabout of any point, it is read as the first one is x coordinate, second one is y coordinate. X coordinate is nothing but the distance along the x axis, y coordinate is nothing but the distance along the y axis. Does it sound okay so far? To everybody? Alisha, Naika, Ashar, Isha. So the coordinate plane just helps us locate. See, you would have heard the term coordinates very often, at least in the current generation. People will say, send me your coordinates. Coordinates are nothing but it tells the whereabout of that person. If I am sending my coordinates to Kian, I am telling Kian where exactly I am. Okay? If Havisha is trying to come to the classroom, she asks me, sir, send me your coordinates, meaning the point, how I locate you. So in the coordinate plane's context also, coordinates are nothing but the value or the means to locate a point. And since we are here, every discussion is happening around or with respect to or with reference to the x and y plane. So you always relate with the x and y plane. Let's say if I'm talking about this point, I'm trying to say how far along it is on the x-axis and how far along it is along the y-axis. So how much distance it has covered in the y direction and how much distance it has covered in the x direction. Or you guys can think of it in another way also. If this is the point, let's think of this like a game, that you are wanting to come to this point, but you are only traveling in the straight line, along the straight line, and without making an angle, meaning you can go this way, this way, this way, this way, this way, but you cannot go this way. Okay? So if I have to come to this point from this place, I will go this far and then go downward this much. So when you look at this one, I went 6 points or 6 units along the negative of the x-axis and then another 4 units along the negative of the y-axis. So this is how you read it also. So how much you travel along x-axis is your x-coordinate. How much you travel along the y-axis is your y-coordinate. Let's say if I come here, if I am at this point, how I can go here? I will say, okay, how much I am going along the x-axis. Let's say this is 7 and this is -1. So I will say I traveled 7 units along the x-axis, 7 units, and then -1 along the y-axis. So this becomes your coordinates. 7 minus 1. Am I sounding okay or not really? Everybody? Aditri, Ishan, Kian, Sandhi, Ashar, Naita, Avisha. Avisha has a very nice background. It feels like she's in Kerala right now. And I love that background. That's in my wish list. One day I have to go to Kerala. I've heard a lot about it. I've never been there. Alright. So coordinate plane and coordinates. Now let's say this point versus this point versus this point. Let me use different color codes so that you guys can locate it better. The yellow one, the green one, the red one, and let's say the light blue one. I have these 4 points. Now what we want to do is we want to make sure that, what is the point? No, that was a bad joke. Coming to this one, let's say if I look at the green point, we are not doing calculation right now. We are just trying to wrap our head around what is happening here. How do I look at this point? How do I describe this point? How do I create a story for this point? This green one. If I have to write an essay on this point, let's say I have to write an essay on the green point, what my essay will sound like. I hope nobody is falling asleep because of my essay. Okay? So this point's essay would be, I can get to this point by traveling 2 units along the x-axis, pointed 2 units along the x-axis, and pointed 3 units along the y-axis. That is the first line of the essay. Now the next line of the essay is, this point is falling in the first quadrant of the coordinate plane. The third line of the essay is, both the x and y coordinates value are positive. Fourth line of the essay is, the teacher is boring enough. There is nothing more to add. But the key concept here I am trying to convey is, if you look at any point in any quadrant, you will see what my x and y values are, which quadrant it is falling into, and what is the direction of the travel that is happening to get to that point. Am I traveling the positive direction or am I traveling the negative direction? And this is very important and critical. Why I am saying so? Because this is going to be your backbone for dealing with a lot of interesting algebra and geometry concepts. We will deal with slope, we will deal with even trigonometry, where all these direction and the magnitude will play an important role. And this will be part of the vectors and complex numbers also that we will talk about. That's why any point that you look at, you have to clearly identify which quadrant it is falling into, and then what is the sign of the x and y components. Okay? It's not sounding convincing, right? Not enough of excitement is created yet. Let me spend 1 more minute and then I will take you guys for a ride. Now we saw first quadrant, second quadrant, third quadrant, fourth quadrant. So how we read it? We read it anti-clockwise or counter-clockwise. We start from this place, go counter-clockwise to second quadrant, go counter-clockwise to third quadrant, go counter-clockwise to fourth quadrant also. And this is how the angles are measured. So this is in line with that. Now other thing is, let's come to the third quadrant. If I have any point in the third quadrant, what do you see with respect to sign of x and y values? In the third quadrant, what is happening to the value of, what is happening to the sign of x and y coordinate values? Both are negative, right? Your x is negative, y is also negative. If you come to the fourth quadrant, what is happening? Your x value is positive, and y value is negative. If you come to the first quadrant, this is x is positive, y is also positive. If you come to second quadrant, your y is positive, x is negative. People end up memorizing it. Oh, second quadrant, x is negative, y is positive. Third quadrant, x, y both negative. Fourth quadrant, x positive, y negative. We don't have to memorize it. As long as you have this picture in your mind, you are good. The boring part of the class is over. Now the fun begins. Now I'll take you guys back to what I started with. Why do we have to even learn about coordinates? And now I will give you a very strong reason why we are learning about coordinate planes. Because think about whatever geometry you know. What do you need for drawing a line or line segment? What do you need? 2 points to draw a line or line segment. These 2 points. If you have these 2 points, how do you know where these points are? That your coordinate plane only tells you. If you don't have the coordinate plane, you would not know where these points are. You cannot locate them. It is as good as me and Isha talking. Okay, we are trying to find out how far is Isha's place from my place. Okay, Isha is not disclosing her address. I am not disclosing my address, and we both are trying to find out how far we are. That's the kind of deal if you are not having coordinate plane, right? So Google Map is nothing. Google or Apple Map, whichever one you use, that is like your coordinate plane. That tells you how do you look at the entire map of US or the whole world. Now when you have the coordinate plane, then you can locate this point and this point. If you have to find out the distance between them, once you have located the points, you can join and find out the distance. And how do you find out the distance? It uses something called distance formula. I'm not teaching that right now. Okay? I don't want you guys to get stressed out right now. But what I'm saying is, we are trying to find, if we have to find out the length or distance between 2 points, we need coordinate plane to locate the 2 points, and then that will help us find out the distance between them. Yeah? Is that a good starting point? Let's say we are trying to talk about a triangle. What do we need for triangle? What do we need for drawing a triangle? And give me very simple, basic, lame answers. I'm not looking for anything intelligent because I cannot digest that. I'm not intelligent. Yes, Anahita.
3 points.
3 points. Hamisha, what do I need? Same thing, 3 points. See, life is making a complete circle for us to relate to things. Now, if I am talking about 3 points, if I need 3 points to draw a shape called triangle, which is going to be an integral part of our learning journey. Without we knowing triangles, we can say we know nothing about math actually, right? Without triangle, half of the math is over, gone. So we need these. Okay, now to draw a triangle or to envision a triangle or think about a triangle, what do I need? 3 points. And if we don't know where these 3 points are, there is no going beyond. So we are stuck here. So that is why coordinate plane helps you find out the source of the things that will help us deal with geometry also. Yeah? Does it sound okay so far? So I will show you guys one interesting thing, and again I don't know whether it's part of 9th grade, 8th grade, 6th grade or 5th grade. I don't really care about it. What I care about is, are we learning something exciting enough? Since I was talking about the coordinate plane, I wanted to show you guys how coordinate plane helps us find out the distance between 2 points. and that is what is called distance formula. If you guys are learning it ahead of time, be proud of it. If you are getting stressed out, you can forget about it, and I promise I will again teach you guys next year. Okay, don't worry about it. So we will look at the application of the coordinate plane to find out the distance between any 2 points. Are you guys ready for it? Yeah. Now let's go a little slow. I will try going slow. I keep promising that I'll go slow, but sometimes I end up going a little faster. So this is my coordinate plane, or 2 number lines meeting at this point. Okay. Let's say I have one point here and another point here. Okay. So far, 2 points. Don't ask me what is the point. These are the 2 points. This is point P1 and this is point P2. Yep. And let's see now, since we are talking with respect to coordinate plane, that means every point will have some x value and some y value. And please stop me if I am not making sense, okay? This is going to be very interesting and important, okay? Provided it makes sense to you guys. If it doesn't make sense, it's one of the most useless things that I am teaching right now. Okay? Alright? So here, this is point 1, this is point 2. Any point in the coordinate plane will have some value for x coordinate, some value for y coordinate, meaning this distance from here to here is x1, and this distance along the y-axis is y1. That's why the coordinate of this point is x1, y1. Are you guys with me so far? Confidently with me? Avisha, Isha, Chandni, Ishan, Aditri, Naita, everybody? Okay. Now same way, this is my second point. It has coordinates x2, y2. When I say x2, y2, I'm just giving some variable value. Okay. So meaning distance from here to here is x2. Okay. And here to here, meaning this distance is y2. Are you guys with me so far or not? Yeah? Yeah, somebody is saying something. Go ahead. No? Okay. So, in summary, so far what I have talked about is that we have 2 points P1 and P2, and their coordinates are x1, y1 and x2, y2. When I say x1, y1 as coordinates, I am talking about distance along the x-axis is x1 and distance along the y-axis is y1. Similarly, for this point, the coordinates are x2, y2, meaning the distance along the x-axis is x2 and the distance along the y-axis is y2. Yep. Everybody okay so far? Adya joined, but I'm not sure from where she joined me, but Adya just, yeah. Okay. So we are talking about coordinate plane, okay? We just started talking about coordinate plane. I just bothered everybody to recap what is our understanding of coordinate plane, why do we need coordinate plane, how do we locate a point in a coordinate plane, what are the 4 quadrants of a coordinate plane. That's how we are talking about, okay? Right now, we are looking at 2 points in the coordinate plane and trying to find out the distance between them. Yes, Anahita, you're saying something.
Sir,
Yeah.
are these the distance for any coordinate plane problem?
I'm sorry, Vika?
So, are these the steps for if the location changes into the other one, then we have to do something else?
No. So, very simple, Vika. If I have any point, okay, let's say this is my point. I have to know where exactly is the point. And in coordinate planes context, the only way we locate a point is by figuring out how far is that point along the x-axis and how far is that point along the y-axis. So this distance, let's say this was k, and here to here this distance was L. So my coordinates will be k, comma L. Now since this is along the negative side of x-axis, this will be minus k. My y is along the positive side, so it will be positive L, that's it. So we are just, coordinate plane is like an address mechanism. It just locates a point, it just tells you the address. It has certain way to define the address. Say okay, like we have our addresses here, right? We say name, house number, street name, right? So in the coordinate plane, these are your street names and house numbers. You don't have street name and house number, you only have two things to relate to. X-axis, how far along the x-axis, how far along the y-axis. Yeah? Or even a simpler way. Let's say if you have this point, you have to find out the x and y coordinate. What you will do is, from this point, you will drop a perpendicular onto y-axis. Oh, this is not a perpendicular. You will drop a perpendicular onto x-axis, y-axis, and you will drop a perpendicular onto the x-axis. And see what is that point on the y-axis. Look at this value on the y-axis. Let's say this says minus 3. And here it says this is meeting at, let's say, minus 4. So x value first, y value next. This is your coordinate for this point. Any point you have in the coordinate plane, just simply drop a perpendicular onto the x and y axis, whichever is closer. Yeah. So you see, when you're dropping a perpendicular, you will end up hitting the y-axis here, not here, right? It will be a negative value in this case. When you drop a perpendicular onto the x-axis, you will hit somewhere here, not here. So you will see a negative value here. If your point is here, then it will drop a perpendicular on the positive side of x-axis and negative side of y-axis. Does it sound okay? Everybody okay? Isha is thinking. Yeah? Everybody okay, right? I mean, see, my only thing, I don't achieve anything by convincing myself. I accomplish by making you guys understand something. Okay? So that's why I keep asking for it. Okay? So now let me do some cleanup here. I created a lot of mess here while trying to explain things to you guys. So let me clean up some of the mess here. Okay. So these were the 2 points we had, P1 and P2. This has coordinates x1, y1 because distance along the x-axis is this much, which I am giving as x1 value, and this distance along the y-axis was y1. That's why my coordinates are x1, y1. Similarly, the second point, my x value is this much, which is x2, and this value is y2. So my coordinates are x2, y2. Up to here, okay, everybody? Now, I am trying to find out this distance. Let me use a color that you guys might like. I am trying to find out the length of this green line, which looks pretty much like a parrot. Yeah? I am trying to find out the length of this green line on the screen. And how do I find that out? What I will do is, I will drop a perpendicular again here and here. So this one that you see now, what I am doing is, I dropped a perpendicular here, this is this yellow line that you see, and this other yellow line here. This is more like a right angle triangle, isn't it? This right angle triangle that I have created by dropping a perpendicular from this point. I am creating a line parallel to the x-axis and here a line parallel to the y-axis, and they are meeting at this point. So let's say if this is P1, P2, and let's say this is P3. P1, P2 and P3 are is becoming a right angle triangle, isn't it? Yes or no? Isha, Adya, Ritri. I will not move on unless I get a confirmation from you guys. Ishan, how about you, beta? Making sense or no? So I'll just repeat my story, okay? If it takes a little bit longer to digest, let that investment happen. That's okay. These are 2 points P1 and P2. This has coordinates x1, y1. So this distance is x1. This is y1. This point has coordinates x2, y2. So this distance is x2, and this distance is y2. Now, what we are trying to do is find out this length. So what I did was, I dropped a parallel line to the x-axis and dropped a parallel line to the y-axis from this point, so that these two can meet at the third point P3. And I'm saying, okay, I have a right angle triangle, a very colorful right angle triangle made of P1, P2 and P3. It's a right angle triangle. So if I have to find out this length, how much is this length? Can somebody tell me? Let me award you guys for a very creative answer. If I have to find out this length, how much is this length? From this point to this point? Let's see who's thinking through it. How much is this distance from here to here? Don't think this as a difficult problem. This is a very easy one, okay? Think easy, it'll come easy. Yes, Ishan.
Can you repeat the question?
I'm saying from this point to this point, what is the length? What is the length of this line from here to here? I would not say line, it's a line segment on length of the side of this triangle from here to here. Yes, Kian. Kian, you have raised your hand. Go for it.
Yes, sir. Sorry. I clicked on something by accident and it opened some random coding.
Okay. Yes, Ishan, tell me, what do you want to say?
So, the line ends at 3, right?
At P3. So this is point 1, I'm calling it P1. This is point 2, I'm calling it P2. This is point 3, I'm calling it P3. So there is a prize for whoever gives me the right answer. Only the first one, okay? What is the distance between these 2 points? Let's see how easy you think about it.
Just 2 units.
I'm sorry?
Just 2 units.
That was a good guess. Not convincing yet. Yes, Anaita. Everybody gets one chance.
Wait, I have a question.
Yeah.
How do you figure out the distance between the sides? Wait, no, what's the length of the sides?
I will come to it. I will explain that and then it will make sense to you guys. But I'm trying to see if any of you are willing to get a prize from me. Yes, Havisha, go for it.
The bottom can be x3. It could be 3.
That's okay. That could be x3, y3, but that's okay. That's the third point, x3, y3. But I'm trying to find out the absolute length or the distance between the 2 points based on whatever information we have. Let's see what Isha wants to add. And Havisha, if you get an answer, you can tell me. Isha, you raise your hand. Go ahead.
I got one of the points, but I'm still not sure about the one of the coordinate for the other point. I thought you were only asking for one of the points, sorry.
No, so I am saying that this point's coordinates are x1, y1, meaning this distance is x1, this distance is y1. This point's coordinates are x2, y2, meaning this distance is x2 and this distance is y2. I'm trying to find out how much is this length based on the information we have. Yes, Anahita. One last chance.
I thought the number was something else.
Okay. Sanvi, what would be your guess? Sanvi, Aditri, Adya. Yes, Adya, go for it.
I'm confused, but I think it's 2.
You think it's 2? Okay. Aditri, Sanvi. I'm just trying to make sure that I'm giving everybody a chance before I jump onto it.
No, I don't know.
Okay. You guys know it, okay? You guys are just being a little bit shy here. See, yeah.
Wait, I think that's all. Can we wait for a moment?
Okay, 10 seconds. Okay. Let's see. Aditri, tell me that.
So is the question the distance between
P1 and P3, yes.
Okay, I got 1.
You got 1.
Yeah.
Okay. Anahita, let's see. You are the only one contesting for this prize. Tell me, what did you get? Now, Adya.
Wait, does P3 count as distance?
P3, see, any point that you see is a point in the coordinate plane. And it has its own identification as coordinates, x and y coordinates. And every coordinate has a meaning to it. Yeah? Havisha, your last chance.
Wait, so I'll change my answer because I thought P3 was counted like as a distance, but I got 1 too.
You also got 1. Okay, Havisha, you have raised your hand. Havisha and Anahita, after that it will be my turn. I will get the prize for myself. Yes, Havisha, go for it. You also got 1. Anahita. Not convinced. Now you guys will see what I'm going to do. See, what is the coordinate of this point? x2, y2. Meaning, this point along the x-axis, this distance is x2, as you can see. Right? Here to here is x2. This point's coordinates are x1, y1. What does it mean? Along the x-axis, this distance is x1. I'm asking you guys the distance from here to here. You know this distance here to here is x2. This distance is x1. So if I use different color, this yellow line is x2. And this purple line here to here is x1. What I was asking you guys was the length of this blue line. So this line plus this line is this much. x1 plus this line, I don't know how much is this length. And that is what we are trying to find out. This plus this equal to this. Or this will be equal to this minus this. As simple as that. This was a visual question. There was nothing to calculate here. When I am saying x coordinate for this point is x2, meaning this whole distance is x2. This much is x2. If this point's x coordinate is x1, meaning this distance is x1. So I am trying to find out this length, which is this length minus this length. So this is x2 minus this length would be x2 minus x1. Here to here. Makes sense or it doesn't make sense? Whole distance is x2, here to here is x2. This much is x1. I was trying to find out this length. So x2 minus x1. Yeah? I mean, it's not about me forcing you guys to believe it. Does it make sense? That's what is the $1 million question. Yeah? It doesn't make sense? Okay, now let me break my hand into 2 pieces. Okay, this is my hand. Yeah? From here to here is x2. Full hand. From here to the algo is x2. Sorry, x1. This distance is x1. This whole thing is x2. If I am trying to find out this length, that will be the whole length minus this length. Yeah. This is my hand. This full thing is x2. And here to here is x1. If I have to find out this length, that will be full length minus this length. That's it. Make sense? You guys are waiting for me to break my hand first to understand this? No, I'm just kidding. Don't take me seriously. Those are dad jokes. Yes, Aditri.
So you simplify the x1?
I am not simplifying x1 beta, okay? I'm not simplifying x1, x2. These are just 2 points. I'm not trying to find out anything absolute right now. We're trying to find out something which is more generic in nature. Tomorrow, x1 could have a value of 5 and x2 could have a value of 9. We'll just plug in those values. That's it. But for now, we are saying, okay, this is x1, y1, x2, y2. x1, y1 can have some value, x2, y2 can have some value based on where the point is located. Right now, we'll keep it open-ended. More like a standard form or more like a generic form. Yeah?
Okay.
So, see, that's why we use the variables, right? Something that we don't want to make specific, when we want to generalize them, we give them a name as variables so that based on our convenience, based on our need, we can plug in the right value at the right time. Yeah? Yes, Isha.
What was going to be the prize?
Prize was, I've been planning to print t-shirt for my math classes. I thought whoever gives the right answer, I will send out the t-shirts for the math classes. But don't worry about it, this is not the last chance. You guys, see, you guys have to just keep enjoying the classes and keep looking for those excitements, okay? Because if you guys stay excited, my excitement goes to the next level. That is how we will enjoy as a group, right? That's why I keep asking you guys, keep motivating you guys. Okay? So now for this question I will not get prize, but now if I ask how much is the length of this side from here to here, what will be that length? See, for this point's coordinate, y coordinate is y2, meaning this length is y2. This point's y coordinate is y1, so this length is y1. If I am talking about this length, if I put that in a purple color from here to here, this length is nothing but this whole length minus this length. So y2 minus y1 will be this length. This length is y2 minus y1. This distance came out to be x2 minus x1. This length is y2 minus y1. Yeah? Now, who knows name of my uncle? I have one uncle, that is your uncle too. That is Mr. Pythagoras. Do you guys remember Pythagorean theorem? Yeah? And what does Pythagorean theorem say? Pythagorean theorem says that if you are dealing with a right angle triangle, which is the case here, if you are dealing with a right angle triangle like this, and this is A and this is B and this is C, meaning C is the side opposite to the 90-degree angle, then A square plus B square will be equal to C square. Meaning the two sides that make the 90-degree angle, sum of the squares of the two sides will be equal to the square of the hypotenuse. That's the name given to the side opposite to the 90-degree angle. So here in this case, this side you found, this side, the horizontal side is x2 minus x1. This vertical side's length we found as y2 minus y1. So if you have to find out the length or the distance between the 2 points, which is your c square, that will be equal to the distance or c square will be equal to square of x2 minus x1, this side's square plus this side's square. or the distance between the 2 points will be equal to square root of x2 minus x1 square plus y2 minus y1 square. And this might be sounding texting to you guys. Don't worry about it. I was not trying to flex my skills or knowledge. I was just trying to convince you guys. Okay? See this is the difficulty of my job. It's not about just me teaching you guys and disappearing. It's about me making you part of a journey that we are wanting to walk together. Trying to convince you that, okay, if you're talking about coordinate plane has a lot of hidden treasures. And how do we decode, unearth those treasures for enriching our knowledge? So I said, if you're talking about coordinate plane, if you have any 2 point in the coordinate plane, how do you find out the distance? How do you find the distance? We are just trying to figure out, okay, if I have any point in the coordinate plane, it has x and y coordinate. This point also has x and y coordinate. What is the distance between the 2 points along the x-axis and the y-axis? That's why we did all that thing to relate. Okay, x1, y1, this is x1 and this is y1. x2, y2, so this is y2 and this is x2. How much is this distance? x2 minus x1. How much is this distance? y2 minus y1, this distance. Now we are going back to Pythagorean theorem and say, okay, fine. This is a right angle triangle now. So this square plus this square will be equal to this square. So x2 minus x1 square plus y2 minus y1 square will be equal to this distance square. So if I have to find out the distance between any 2 points, it will be equal to difference in the x coordinate value square plus difference in the y coordinate value square root. That is called the distance formula. If you guys are learning it ahead of time, you guys can feel proud of it. If it is sounding very complicated, you can take it with a grain of salt. That you will again learn it. Yeah. So coordinate plane is not just about quadrant 1, quadrant 2, quadrant 3, quadrant 4. No, this is your foundation for the house. How strong your house is going to be is going to depend on how do you locate a point, how do you relate the concept around it, how do you kind of break any 2 point in the form of x and y coordinate values, and what does x and y coordinate value mean to us? How do we use that information to go beyond? So you guys have your school started, or it's probably starting tomorrow for some of you. You can, no matter what, if somebody says, if you go and meet your friends after a gap of 3 months, you can just go and say, you know what, there's something called distance formula. Do you know what is that? And say distance between any 2 points is equal to the square root of x coordinates difference square plus y coordinates difference square. Go brag about it. You are not trying to impress anybody. Actually, you are trying to memorize it for yourself because we just saw it. So it's like you learn something, you muddle the water enough so that that concept becomes yours. Okay? Let's see who all goes and brags about this distance formula to your friends. Even if they get confused, it's okay. Let them get confused. Let them start respecting you more. Oh, Anahita knows distance formula already. I never heard about it. Sanvi can talk about distance formula. Wonderful. Ishan, wonderful. I love it. This guy looks easygoing, but he knows a lot of deep concepts. That's how you guys can build it for yourself. And see, do you think I derived these formulas? No, I'm just borrowing somebody else's knowledge to impress you guys, isn't it? You do the same thing. Yep. And with this one, what will happen is, tomorrow, let's say, somebody will say, I have 2 points in the coordinate plane, 2, 1 and 5, 7. Find out the distance between these 2 points. This is where the distance formula will come to your rescue. Oh, this is point number 1, P1. I will say this is x1, y1. So my x1 value is 2, y1 is 1. Yes, Sandy.
Okay, so I was wondering because like we've already done this in the past in my classes. So would you refer to distance as slope too? Like, are they like the same thing, or are we referring to them differently?
No, say it one more time.
Are we is slope and like distance like the same thing? Are we referring to them as the same thing?
No. Slope and slopes again. So slope and distance are two different things. Now let's get our understanding around this one. Let's say I have this line. This is a line, okay? This line versus this line versus this line versus this line. They are all different. Why? They have different slope, different level of how steep they are. Yeah. So this one you will say this has less slope, this has more slope because it's getting more and more steep, more slope. So slope of any line is nothing but rise over run. That's how you relate it mathematically. Any line's slope is nothing but rise over run. Now, what do I mean by that? Meaning, for this much of run is along the x-axis, rise is along y-axis. Rise over run. So look at these two lines. You should look at these two lines. Between these 2 points, for the same run, this guy has this much rise and this guy has this much rise. Not rise and pulses. Rise, R-I-S-E, okay? Not R-I-C-E. Okay, so rise over run. So here you will see that for the same amount of run, this has more rise and this has less rise. If you are looking at this line, see, for same amount of run, see how much is your rise. So basically, with higher slope mathematically means there is more rise for the less run. So look at this line now and look at this line. Here I have more slope, here I have less slope. If you pick any 2 points, let's say this one, and look at this one. For same distance of run, this one has this much rise. For this same distance of run, this one has more rise. This has more slope. So that is how we relate to it. Now the distance when we are talking about, we are talking about, see, in case of line, can I say my line is 20 centimeter long? No. Lines don't have fixed length. They are just representing direction. We always measure the distance of line segment, a piece of a line. So the distance that we are talking about, that is more with respect to the piece of the line. The 2 points, 2 fixed points here, this point and this point, and the absolute distance between them, that's the distance. Whereas slope says how steep or shallow it is. Yeah? Am I sounding okay to everybody?
Yeah.
Yeah? So, and see, you will find that a lot of things start jumbling together, okay? They get jumbled up. So we have to keep separating them. It's like finding out the pearls from a bag of lot of things which may or may not have valuable stuff. Okay, so these are your pearls that you are collecting. We are just trying to make sure, we are trying to tell ourselves that okay, distance between 2 points is the absolute distance. I can take a tape and measure the distance between them. If I am talking about slope, this is one slope, different slope, different slope. Yeah, you guys have all gone to the parks during your childhood days. Imagine sliding down a slope with this kind of a steepness versus sliding down a slope of this steepness. You're not sliding, you're falling actually. Yeah. So those slopes are designed in a way that it works with a lot of physics behind to make sure kids are not falling. Okay, so or it's not designed like this where kids have to literally walk to slide down. Yeah. Alright, so we talked about slope and distance. Now just to conclude this one. So these 2 points we had, and somebody says find out the distance between them. you will have to not worry. This is your point number 1, which relates to x1, y1 kind of thing. This is point number 2, x2, y2 thing. What you will do is, distance between the 2 points is square root of difference of x value, coordinate value. So x2 minus x1 squared plus y2 minus y1 squared, and you know your x1, y1 values. Your x2 is 5 minus 2 squared plus y2 minus y1, 7 minus 1 squared. So this became 5 minus 2 squared is 3 squared, that is 9, plus 7 minus 1 is 6, square is 36. So this became square root of 45, that's it. I know, I was just talking non-stop, without wondering or without bothering whether I'm making sense to you guys or not. But did I do okay or did I do a horrible job? Okay, Isha, Aditri, Avisha, Ishan started from here, he was almost tilting towards, no, I'm just kidding. Alright, have fun. We'll see you guys tomorrow. And not tomorrow, day after. Yeah, alright, bye bye, good night. Bye bye, bye bye.